Hi everyone. Did you know supervised learning methods require a lot of training data to train a good model? A recent study has found that a random forest-based classifier requires at least 1.5 million training labels to link two fairly clean databases with a precision and recall of 99%. Acquiring a lot of training data is labor-intensive and costly. To address this problem in the context of entity resolution, we proposed a new framework, TransER, Homogeneous Transfer Learning for Entity Resolution. This research was conducted by myself, that is Nishadi Kirialla, along with Professor Peter Kristen and Dr. Thilinaran Baduge. We all are from the School of Computing of the Australian National University. First, let's look at what is entity resolution. Entity resolution is the process of linking records that refer to the same entity across one or more databases. As shown in the figure, let's say we want to link records in database A with the records from database B. If we compare every record pair between the two databases, the comparison space becomes quadratic. Therefore, the first step is to conduct blocking, in which we group similar looking records into blocks. Then in the record comparison step, the attribute values of record pairs in each block are compared using similarity functions. This step generates feature vectors for each compared record pair. Now these feature vectors are used in the classification step to train models and then classify them either as matches or non-matches. And then in the final step, we evaluate the linkage quality. As of now, we can see a lot of efforts in entity resolution more focused on supervised learning because of the high linkage quality that can be obtained with sufficient labeled data. But the problem is with obtaining these match and non-match labels for record pairs. As research shows, supervised methods require millions of training data to obtain high-quality results. The process of obtaining these labels is manual and require extensive human efforts. Therefore, we need to look at the alternatives. An intuitive approach to avoid this tedious labeling task is to utilize labels from an existing labeled dataset. That is what is done in transfer learning. Let's say we want to label a dataset and we don't have any labels associated with that dataset. But we have a relative domain where we have already labeled data. The process of utilizing a source domain with a different distribution to label a target domain is referred to as transfer learning. In this process, the source domain has feature vectors xs and labels ys. But the target domain only has feature vectors xt. Our goal is to find the labels of target domain yt using xs, ys, and xt. Now let's see how to apply transfer learning for entity resolution. Entity resolution literature has a limited number of research on applying transfer learning methods. Interestingly, all these approaches are based on deep learning methods. The drawback in deep learning methods is that they are better suited for long textual data. But research shows deep learning methods are not providing sufficient results for structured data with a limited number of attributes. What are the challenges associated with applying transfer learning to entity resolution? Before talking about those challenges, it is important to note that we consider homogeneous domains in this context. Homogeneous domains have the same feature space, that is the same set of attributes. In the context of entity resolution, it does not make sense to use a completely different set of attributes, such as in the heterogeneous case, because the effect of different attributes varies for the linkage decision. The first challenge is that the source and target domains can have different marginal probability distributions because the features are drawn from two different domains. Second, we can have different class conditional probability distributions in two domains. For example, the same feature vector can be considered as a match in one domain while a non-match in the other domain. This is commonly seen in entity resolution due to the limited number of attributes available in the datasets. The final one is a common challenge in entity resolution. Due to the small number of matches compared to non-matches, the data distribution has two peaks. This makes it harder to apply existing transfer learning methods to entity resolution. To overcome these challenges, we propose a framework, TransER, Transfer Learning for Entity Resolution. This framework has three key phases: instance selector, pseudo-label generator, and target domain classifier. Let's see how each of these phases contribute to our framework. In the first phase, we select candidate instances from the source domain to be transferred to target domain. In this, we select source instances that are likely to have the same label in the target domain. As we are avoiding source instances that can have a different label in the target domain, we are addressing the problem of class conditional probability distribution difference. However, we don't have any class labels in the target domain. Therefore, we make two intuitive assumptions. First, for a source instance to have a similar representation in the target domain, it has to have a high label confidence in the source domain itself. In this figure, let's consider a neighborhood of 7 instances for the instance XS. We can see that the neighborhood of XS has 4 matches and 3 non-matches. Since XS is also a match, the confidence of being a match is 4 by 7. When this confidence score is high, there's a higher chance of XS having the same label in the target domain. Second, we assume that an instance has the same meaning in both domains if marginal distributions of an instance in source and target neighborhoods are similar. To measure this, we calculate a similarity based on the distance between the centroids of neighborhoods between the source domain and the target domain. Based on these two assumptions, we select source instances to be transferred to the target domain. After selecting instances for transferring, we have the set of source instances that have a similar class conditional distribution to the target domain. If we use these selected instances to train the target classifier, we still might have a different marginal probability distribution. To overcome this problem, we first train a classifier on the selected source instances and obtain pseudo-labels for the target instances. Then, we use the probability of each pseudo-label to choose highly confident target instances. Then in the third phase, we use the target instances with a higher pseudo-label confidence to train the final classifier. With this, we overcome the problem of different marginal probability distributions. In addition to this, we also address the problem of class imbalance by balancing match to non-match pseudo-labels in the target domain. This final classifier, trained on balanced and high confidence pseudo-labels, is used to classify the target domain. With these three phases, we address the problems of different class conditional probability distributions, different marginal probability distributions, and class imbalance. Then, we conducted an experimental evaluation on 8 different datasets by coupling related datasets as the source and the target. To measure the linkage quality of our framework, we use linkage quality measures of precision, recall, and F-measure, and compared the results of TransER with 6 different state-of-the-art methods. This table shows a comparison of average results obtained by each method on all datasets. It's important to note that TransER provides comparatively better linkage quality compared to all other state-of-the-art methods. We further discuss the runtime comparison, scalability analysis, parameter sensitivity analysis, and ablation analysis of our framework in the paper. In conclusion, we presented a novel transfer learning framework that addresses the challenges specific to entity resolution. As future work, we plan to explore methods such as heterogeneous transfer learning and active learning in the context of entity resolution to improve linkage quality. The implementation of our TransER framework can be found at this GitHub repository. This is the end of my presentation. Thank you for listening.